Hello everyone, welcome to Study Guide Follow. Today we'll be looking at the basic principle of Metre, Bridge and Wheatstone Bridge. So when we look at this is a diagram of a Metre bridge and a Wheatstone bridge. What we do with this instrument is we use it to measure the unknown resistor, the value of unknown resistor, because we know that resistor resistance is directly proportional to length. So as the length increase, the resistance will also increase. So and then from here we look at it very well, we find out that we have what we call, this other one stand for the galvanometer, and this meter bridge has this length from P to Q is 1 meter. That is equal to 100 cm. So whenever at the points, each point where the galvanometer reads 0 in the deflection, where it did not deflect, means that it's equivalent to the reading of this. For example, when we move from this point to this other end, from P to this point, I can say that this one is what we can call it our perhaps C. So from this point PC, what we have here, if this galvanometer reads 0, it means that it's equal to the resistance. Remember, we have it as resistance is direct proportional to length. In other words, the standard resistor, the to get the length of that's equivalent to the standard resistor will then be 100 minus L minus the length, that is L1 minus L1. And we can also call this place. This place can be seen as what? Consider as this 100 minus L can also be considered as L2. In other words, making it x over L1 equal to x over what? L2. They are still the same thing. So this is what we use in order to get our value whenever we're doing this calculation. We want to determine the value of unknown resistor. So here we have the key, the cell that generates the current around this meter bridge. This other end we have a Wheatstone bridge. In Wheatstone bridge, the process of this of the meter bridge and Wheatstone bridge are relatively the same. But in this case, we have three known resistors. We have three known resistors. One, two, we can say 1, 2, 3. Then one of them is always unknown. Now, we use what happened between this arrangement to determine the value of the unknown. Here, I1, the current passing through here and current passing here is the same, and the current passing here and there is the same. But the total current passing through them is addition of the current passing here and the current passing here. That is what we have here. I1 plus I2 will give us the total current. Now, the voltage that is in here is different from the voltage that we have here. In other way around, whenever the resistor, when the key is open and this other key is on, we find out that once there's no deflection here, it means that everything has balance. Then you can take the reading of each of them, and we can also use whatever we have to determine the value of the unknown. Perhaps if this one is the one we're looking for. So that's how we do this calculation. But I want to encourage you, if you have not subscribed to our channel, make sure you subscribe. That's the way you encourage us. That's the way you support us. And then I will also encourage you to see to the end of this in order to really see how we do use this relationship to do our calculations. Here, in this case, to calculate the value of each of the resistance, we have it to be I R1 over what? R2. That means R1 over this, R2, R3 over what? R4. You get the value. So the next thing we are going to do here is to look at some calculations that will help us to understand how to do this, handle these two instruments. So that's the next thing we're going to do now. Okay, now let's look at the question we have here. So that this balance point, the balance point of this place is what 30 cm. 30 cm. So that this is a meter bridge. X is what we don't know, the unknown. This is the standard resistor, which is known to be 40 ohms, sorry. And the balance point from this other end of the unknown is what we have from P to that end. We have it to be what 30 cm. The question said find the value of X. In finding the value of X, like we have already stated the relation, we have the relation to be L1, which is equal to x x over 100 minus L1. So what we do next, since we know that the x is this and the L1 is what? L1 is 40, and is it 40? Which one is 40? Okay, L1 is 30 cm, 30 cm equal to the resistance. The standard resistor we have is what? 40 all over 100 minus 30. 100 minus 30. So now 100 minus 30 will give us, that will give us x is equal to 30 equal to 40 over what? 70. So when we cross multiply, it will be x is equal to 30 times 40 all over 70. So what we'll do here is perhaps we can just cancel out. What next are we going to do? Okay, 40 4 times 30 divided by 7. We have what we have there will be approximately 17 points, let's say 17.1 watts ohms. That's the final answer for this. So remember, this is our relation in solving this problem. Always remember that by substituting whatever you have here, you will get the final answer. Let's try another question in regards to this to see what you are going to get, and then we will try again the Wheatstone Bridge. So the next one we're looking at here said that when unknown standard resistor of 4 ohms is connected to the 0.0 cm end of a meter bridge, the balance point is found to be 60 cm. What is the value of the unknown resistor? So here, if we are to make a drawing of it, let me just see how far I can go with making the sketch of that. We have something that will look like this. Say that the standard resistor is what? 4 ohms. This is the zero end. You can say that this is a zero end, 0.00 end of it. Then we have this is the one we don't know, the unknown. This is this should be our 100 cm. This is 0.0 cm. According to the question, the end of it, the standard resistor is connected to this end. So that the balance point of this is found to be where? 60 cm. So that means the balance point from here, from this 0 point to this other end is what? That means we have our galvanometer, which points at this point, this end of it, we have it to be 6 cm. So say that what will be the value of this? What will be the value of this? looking at this, what are we going to do here? We know the value of this, we don't know the value of the other one. And we know that the relationship we have here, the relation is that um, arrow, this arrow 1, we can call it arrow 1 now, over L1 equal to arrow 2 over L2, which is something as we can say we have it like what we have done so far. 4 ohms over what? Length. This length, is what? 60. Then this other one would then be x over what? 100 minus 60. So that's what we have. When we subtract, we have 4 over what? 60 equal to x over 100 minus 60 will give us 40. So the next one is that we cross multiply. If we cross multiply, we'll have 60x equal to 4 times what? 40. 4 times 40. So now x will then be equal to 4 times 40 all over 60. So we can cancel out. We have 4 times 4 is equal to 16 over 6. To give us, let's just see calculator. This we have 3. Here will give us 8. So this other one will give us let me use calculator to do this thing fast like this. I want to stretch my brain. 16 divided by 8, that will give us 2.7 ohms. 2.7 ohms. That will be the value of the x, the value of the s. That means s here is equal to 2.7 ohms. So let's look at how we can solve. The next one is how to use the Wheatstone Bridge. Now what we have here is a diagram of the Wheatstone Bridge. In this Wheatstone Bridge, we have the arrow 1 is unknown, arrow 2 is what? 40 ohms, arrow 3 is 60 ohms, and arrow 4 is 20 ohms. So it says find the value of arrow 1. Now remember, from the formula we have done so far, arrow 1 is over what? Arrow 2 equal to arrow 3 over what? Arrow 4. So that arrow 1 is unknown. Arrow 1 is unknown, but we know arrow 4, arrow 2 will be 40. Arrow 2 is 40. Then arrow 3 is what? 60 all over arrow 4, which is 20. So what are we going to do now? What we're going to do here, I think we can cancel out. This can also cancel, and then we have this one will be 3 over 1. So to get the value of the arrow 1, will be multiplying this. We have 1 already here. That means to this cancel, we have 1. Arrow 1 multiply 1, we have arrow 1 is equal to 3 times 40. That will give us 1. 3 times 40 should be 120 ohms. 120 ohms. So this is the final answer. Thank you so much for coming this far. We want to thank you for getting to this point. And if you have not subscribed, like we said, we would like you to do the subscription. That's a way of encouraging us to do more. And if for any reason you want to talk to us directly, you can go to the description section of this channel. You see our Facebook page there. Our Facebook page link, you can go there. You can also communicate or chat with us via the Facebook link, or you can as well call us via that channel platform. Or alternatively, any question you have again, you can leave it there as a comment. we will always attend to you speedily. Make sure your friend knows about this. Anyone that you think that will need it, you can share, like, and then subscribe. Thank you so much.